Hello, testing, testing. Sorry, I was playing around with some settings. Time for another late night live stream. If you're listening to the replay, thanks for checking it out. And as usual, I'll put chapter stops in later to clue you into where to go for the things you want to see the most instead of just watching it blindly. I know that's how I like to see streams sometimes. I'm going to jump to the good parts. So, anyway, using some black hole web-based ambient generation music because again I don't have the patience to make 3 hours of ambient music on my own. Just much shorter stuff than that. And this one sounds pretty cool, so has some custom settings. Every time I fire it up, it's a little bit different. So anyway, let's get to the stuff. I have this little app now that I can use the cursor, so that'll help point some stuff out. Hopefully that shows up okay for you guys. Anyway, so raining like hell around here lately, and I decided to get some fresh water samples. And instead of going to the typical marshes and ponds and things like that, I wanted to check a couple ephemeral water sources that should be active enough. They've either been wet for a while, or may have been wet for only for a day or two. First one is a bottle of water I collected from a large puddle with some decaying leaves from a strip mall parking lot. So it's pretty clean water, but it's been around long enough that there might be some critters in it already. So we'll just take a look around and see what we can see. Let me check the focus on this guy. Let's start with this little air bubble here. Just double check the focus. Make sure we're all good there. Okay, cool. Alright then, let's see what we can find. Please join the chat if you have questions or comments or whatever. Always nice to see when people on here and have some interactivity. People ask questions or complain about something that's wrong or other interesting comments. I have a lot of music friends that jump on here, so we talk a lot about music tech and synthesizers and stuff. But hey, if you're not into that, it's okay. But if you are, you can join that conversation as well. Let's see what that is. That's in a different focal plane. It's interesting. I didn't think I put that much water down, but maybe I did. So I'm seeing lots of cells here of, as I expected, decaying matter. There's some decaying leaves and stuff in the water. Not seeing any live specimens yet. Lots of air bubbles here. There's the edge of the cover slip. You can see is very shadowy. Get a better angle so you can see it here. The OBS stream tends to cut off the view on this a lot, so I have to compensate. There's an example of the edge of the cover slip there. There's a little bit of a chip on it, looks like. So let's go through a few sections here. So far it's pretty dead. It's just a lot of random loose cells that are, again, decaying material. Nice thing about these decent scopes is you have an XY stage, so I can just basically do a quick pan and scan and not miss anything to sweep through, kind of like you'd mow the lawn, sweeping through in a back and forth pattern. It's pretty low power. This is 40x right now. And the way you get that, if you don't know, is 10 power objectives. I'm sorry, 10 power oculars, which is the eyepieces I'm using right now, the camera's acting as an ocular, because it's a three-point compound microscope. So I'm simultaneously sending to a tube where the camera is, as well as my binocular viewer, and so the camera roughly approximates what the 10 power is on the oculars. So 10 power times the objective, which in this case is a 4mm, so 10 times 4 is 40. The other objectives are, there is a 10 power objective, or sorry, 10mm objective, so that'd be 10 times 10, that's 100. And then you have a 40 power, so that'd be 400. And then there's an oil immersion objective, which is 100 power, and that's 10 times 100 is 1,000. So that's where you really get to see crazy cell details, bacteria up close, at least as close as you can get with an electron microscope, and a few other things. But it uses a special oil immersion lens that you have to put a special drop of oil on the lens, because the refractive index of air causes too much distortions in the eyepiece. So you end up having to do the oil. The refractive index of the oil they use is a special kind of oil that bends the light correctly. So you get nice magnified views without chromatic aberration and other kinds of focus issues and stuff. It's pretty neat stuff. And you can get a microscope that's $200. It will have some of those features, so that's not out of reach like it used to be. But this is a significantly more expensive scope, but not crazy. I definitely have to save up for a really nice one, like a differential interference contrast microscope, but those are about $5,000 starting price. But the image quality is unreal. So again, lots of boring stuff on this. This is just a random puddle, a good sized puddle on a parking lot with rotten leaves and stuff. But it's always worth a shot. Alright, so let's see. What else can I find? Let's make one more slide and I'll give up on that bottle. I think it's pretty dead, unfortunately. And again, these ephemeral puddles are not expected to be teeming with life unless there's like a dead bird in it or something like that, because you know, it takes a while to life to land in it, to propagate. So it's brought there by the car tires driving through it, people walking through it, blowing on debris like leaves. You know, again, birds walking through it, dogs walking through it, whatever, will deposit goodies in the water. And so it is a totally random assemblage of stuff. All right, what do we got here? Let's make sure I got the edge of the slide. There you go. You can see some cool sorting out of the water balance there. There's a little, like a flume. Need some more light on this guy. There you go. You can see things flying by like they actually have a purpose, but it's just simple diffusion, sorting out the osmotic balance essentially of the area. And I've messed it up by putting the cover slip on it, so some of the concentrations get separated and then they start to separate out. Plus you can see the curvature there a little bit at the top. You can see there's actually kind of a curvature to the water, forming similar to what you'd see in a test tube with what's called a meniscus, where the water flattens out on the glass, and then because of surface tension, the water actually kind of bulges out a little bit. In this case, bulging up instead of bulging down. And it gives it a 3D look because the surface tension makes it form that kind of curvature. Same thing that makes it basically form a circular raindrop, a spherical raindrop that you'd see when rain falls, and then wind will basically change the shape. But all this movement is not life-based movement, it's just simple diffusion. So far nothing. Pretty damn sparse, actually. Again, some decaying material. Edge of the slide, the cover slip. Looks like a little plant material there. More random bits of stuff. Some of these could be actual fibers of things, not just plant material. You get some colorful stuff sometimes with bright colors, blues and reds and stuff. Those like industrial fibers from clothing and blankets and stuff. But right now I'm just getting a bunch of dead clumps of cells. Let's take a quick look at that just to see. Maybe it's interesting. Yeah. It's kind of a gelatinous. Change the light levels a little bit here. Yeah, that's more color accurate there. Just a clump of cells from something nondescript. You get these little crystalline formations from stuff, often forming as the slide sits here and starts to dry out, but it can be for any number of things. Not sure what those are exactly. Interesting patterns though. Nothing alive. Oh well, again, always an adventure. You never know what you're going to find. Let's try next bottle. This next bottle was in a big puddle on a walking trail near a freshwater marsh. That particular one, I didn't have easy access to the marsh itself to get a sample. I needed my extender pole, so I don't get my. If you walk in the mud in the freshwater marshes or even the saltwater marshes, you can often just sink into a layer of muck that's not apparent at the time. You think, oh, that's got to be solid ground. No, as soon as you put your foot in there, you can go up to your knee sometimes or further, and the suction can make it hard to get out, and also you can lose a shoe. And now you're walking around with a muddy sock because your shoe has been swallowed up by the mud. So not the best idea to go trudging around where you're not used to walking. So the quick thing to do is use some kind of a catch pole thingy. Okay, they have those golf ball extenders for golf balls. It's like a telescoping pole with a little cup on the end of it. Use something like that and attach a bottle to it, and then you can get some water samples that way. But in fact, if you know one funny story about the golf ball thing, you guys ever heard of Star Wars Kid? It's a famous meme on, well, actually one of the original memes on the internet, really famous. This poor kid was, he thought the golf ball retriever for the school he worked at, or volunteered at, or whatever, in the studio, they had like a sports area, and then there's a TV studio nearby. For some reason, there's a golf ball catcher thingy in there. He thought it looked like Darth Maul's double lightsaber staff. So he does the most wild, crazy, multiple take video of Darth Maul and the kid was quite overweight and dressed really, not flatteringly. So it made a very funny, bizarre video of him doing it. Of course, his friends embarrassed him by putting it on the internet after the videotape went circled around the school. Kind of like the South Park thing, the original South Park episode that started on videotape, going through friends and then eventually got on the internet, and then it got so famous they made a show out of it. But anyway, it's fun to go watch it, and they've actually done like a Lord of the Rings version of South Park, of the Star Wars kid. They did a Matrix Reloaded, where he takes on all the agents. They've superimposed him fighting all the agents with the staff. There's a lot of like clever people that kind of enjoyed the kid's embarrassing video and made some other funny videos out of it. But anyways, that's the golf ball retriever made me think of that. But so these are again easily captured because I didn't have the right equipment to go trudging around. So this hopefully is a whole lot more interesting because there's a much more animated area as far as like lots of more decaying material, some mud, lots more foot traffic I think in this area. And so it should have something cool in it. But again, I don't pre-check any of this stuff. This is all done live with fresh samples most of the time if I can get them. And so you're exploring this along with me. I have no idea what I'm going to see until I actually put it up there. Let's have a look. All right. What do we have here? Hoping to get at least a few critters in this one of some kind. You can see the particles moving again as the water balance sorts out. Some plant material, something there. Yeah, I got 2 overlapping cover slips. I got 2 by accident. Some more dead material there. Let me fix the center. Why is it not centering? I see what happened. Got a camera pause. There we go. Sometimes the camera doesn't refresh. There's some debris. Nothing else so far. Again, I'm at low power because the easiest way to do a quick scan until something pops out. As scanning higher power is interesting, but it can take forever. More debris there. Still nothing. Still nothing. Well, that's too bad. More chunk of material there. Clump of cells. Let's track that one. I mean, that was a little more interesting than the last one. At least it's a stack of cells. You can see that. Or one of the decaying leaves. And just for kicks, go a little higher just to see. But this low depth of field is very shallow, so. Alright. Nothing there other than a clump of stuff. Don't have any live chatties yet. So I'm just making sure nobody pops in I missed. Okay. Everything looks fine. All right. Some discoloration now, that's interesting. All right, so that slide is awash as well. Let's make one more from that bottle. We'll go into one more bottle from a different part of the same area. An area that looks like it had water for a little bit longer. Probably no foot traffic, maybe some cars grazed it. May have brought some stuff on the tires. Let's shake this guy up a little bit. Let's see, got some leaves in here. Something will shake loose, I hope. A little bit of tint to the water, so there was some kind of very thin mud mixed in with the water. So hopefully that something was caught in there too. Never know. All kinds of things moving, but only from diffusion. Fix this focus a little bit. Okay, I need to make a quick adjustment here. Looks like my two focus sources are slightly off. Let's fix that right now. Okay, I think that's better. No, that's not better. Hold on. It's a little better, yeah. Okay. Hunt, hunt, hunt. What do we got? Some little random bits. Some air bubbles. Oh, hey, we got something. And man, I don't think I've seen one of these in a long time. This might actually be a Volvox. Very cool. Very, very cool. Let me fix this light on this guy. Yeah, looks like it's a Volvox. Or something very similar to it. Like there's another called Gonidium. This is basically a colonial algae. Basically a bunch of things get together, form a ball of cells. You can see the ball structure there. And kind of like a Death Star, but made of balls instead of metal plates. And this deserves to be closer, closer, closer. Very nice. It's usually a little more green than this. I'm not quite sure which one this is, but you can see the material moving around it because all the cells attached have little cilia in them. Or sorry, flagella that beat. But on second inspection, this may be... Yeah, this is weird. I'm not seeing the flagella. Normally on the Volvox, you can see the individual flagella. This could be more of a ciliate with a bunch of food vacuoles in it. That's always the fun thing about this. If you haven't seen some of these things for a while or forever, it's kind of a mystery for a while until you study it a little bit more. It's a very cool one now. Very nice. Needs more light though. It's not. Let me change the light levels here a bit. Give a little bit of dark field, might make it interesting, or at least oblique lighting. Not quite getting the brightness I want to get here. And to adjust this some more. Alright. Let's get a little bit of this, a little bit of that. That'll give me some more detail. It's a good size though. This is 100 power. And maybe about the length of a paramecium, something like that. Maybe a little bit bigger. You can see how it's clearing a path, sweeping through, knocking things aside. Little particles go flying by. Yeah, I'm gonna have to look this one up. I'm not exactly sure what it is. It's acting like a very large, slow ciliate. Oh, some air bubbles changing shape there. Look at that. Air bubbles moving along. Okay, where'd you go, guy? There you are. Well, slow enough that I could zoom in further real quick just to see what we can see. Oh, that's nice. Okay, it's definitely membrane-bound structures inside of a single unit. So it's definitely a cilia of, oh, wait a minute. Yeah, there you go. As you can see the cilia now. But they're not like the thing I was talking about before, where they're gathered around in a sphere. It's actually, these are, whatever you're seeing is contained inside of that single cell membrane, just like one of your cells. And you can see the cilia as I change focus. Little blurry lines moving around. This might be there's one called blepharisma, which is a very large ciliate that often has these structures in it, but not always, from what I've seen. And oh, you can see that is cool. Do you see that thing moving the back end there? That is contractile vacuole, I believe. That structure on the back end that's kind of opaque, kind of white colored, changing shape. That's a contractile vacuole. So if you saw some of the other videos where I had some cells dying on the slide, contractile vacuole is important for osmotic balance of the cell, because just like your cells in your body, they have a higher salt concentration than the local surrounding water, and water tends to enter to balance out via osmosis the concentration gradient. Oh, he's whipping that bacterium around. See that little rod going floating by? That's a bacterium. That's wild. Anyway, so just like when you go into the bathtub and your skin absorbs water and swells up because your skin's another form of semi-permeable membrane with a little bit more stuff going on there, and your body will absorb that water because you're higher concentration of salt compared to the water you're in. And these guys on a tiny scale do a similar thing. And if the active transport from the contractile vacuole doesn't push the excess water out on a regular basis, they will inflate and pop. And they certainly do that when they die because the active transport is no longer happening. So when you see those other videos I have where the cells are dying, the cell has just either from age or from something in the water it didn't like, or the heat of the lamp over time, it just stopped functioning properly. And as the cell dies, the cell will basically lyse or split open from water pressure, pop like a balloon, kind of, sort of. Yeah, this is a nice specimen. This might be blepharisma. Let's look this one up. You see it's kicking stuff all around it. As all the cilia hits things, it's batting everything aside. And when it's potentially swimming harder, like something like a rotifer will do, you'll actually see currents from it forcing stuff floating around at different directions. So we'll go back to the back of the cell. You can see that area I'm talking about. Well, back in the way it's moving the other direction, but you can see that section right there in the middle of the frame. It's kind of light colored, gray. Watch it expand, and then watch it contract. There you go. as it pumps out that water. It's hard to do this with only a couple hands here, but using the cursor here, this area right here, you'll see the expand and contract. Here it goes. Keeping that water balance. This other white section here is not doing that. So it's either vacuole it's not currently doing, contractile vacuole it's not working, or it actually could be part of the nucleus. It's hard to tell from this angle. Very nice. I need to go a little low powered so you can see the whole guy again, because I'm even having to keep move it, and it's constant focusing gets difficult. So now you can see how it's slowly moving. You can watch the back end there. Watch the contractile vacuole go. There it goes. Nice slow moving specimen. Makes it much easier to study and to get better shots of it. I'm going to try and do a little bit of a dark field here if I can. It's not quite playing along with this objective. See if that will do it. Nah, it's not cooperating. So let's use that setting for now. Yeah. Oh, it's really slow. I'm going to change a setting here. See if this helps my adjustments. I think one of these will work. Let's check this one. A little more contrasty there. Not crazy different, but a little more. That's the back end. Here it goes. There you go. So it's slow moving, but it's still got some cool functions to look at. Uh-oh. See that little, looks like a gust of wind went through there? That's an early sign of the slide starting to evaporate and dry up. Which means I have to try and put this guy back into the bottle before he gets dehydrated or crushed by the changing current of the slide. That's a nice little find. So this was bottle number 2. I think it's bottle number 2. Is it bottle number 2? Yeah, it was bottle number 2, the one on the trail. It had some mud and other plant bits in it. I think I got the music and speech balance correct on this. If anyone joins the chat, they can let me know, but yeah, there's that wind current again. That little whoosh is going through there. Yeah, slide is starting to dry up. You get like a wave front coming through as the wall of water starts to shrink. Alright, I should give this guy a break. I don't want him to meet an untimely demise, so let me get him back in the bottle. Okay, so that's it for that slide. That was pretty good. Let me make another one off that same batch. So far, so good. Then I have some stuff from the kitchen to look at. It's always fun to look at items from the kitchen. Some people like critters, some people like kitchen food stuff, so it's good to mix it up a bit. See what's what. Alright, let's see if that finds anything good. I grabbed too many cover slips again, I think. Alright, what do we got here? Oh, very fast. Whoa, that guy's really fast. And that is a flagellate. It's a very small one. Moving super fast. Could probably, if he's staying in a small area, I can probably get a piece of it. There you go. Boy, oh boy, that's fast. Come on. This is like the hardest video game in the world. They're following this guy around, focusing. Because they go up and down in the thickness of water, so it goes in and out of focus. Where are you going, guy? Usually when they stay like this, they move for endless amounts of time, back and forth, up and down. So there's a fun trick. I will come back for him since he's not going anywhere off the slide. Oh, there's another one. Yeah, this has some good stuff in it. That was a little bit slower. So this one's off the cover slip. You can see the thickness of water there. It's kind of blurry. And he's going in and out of focus as the water is thicker. Makes it very challenging. That's two good things so far. What else we got? There's a trick I can do for fast moving things. Just like if the air were much thicker and you try to run through the air, like how competitive bicyclists and competitive swimmers, the men often shave their legs and arms and stuff just to minimize every bit of wind resistance or water resistance they can get. But no matter what you do, you know, the air compared to us, our experience of the world, the air thickness is negligible. But if you were to make it much thicker all of a sudden, you would move a whole lot slower without putting out, unless you put a ton of effort out. So there's a trick you can do with the stuff they use to make slime in movies. Oh yes, there's a rotifer. Yay! Love rotifers. And something else too. Wow. That is a nice one too. Man, this slide is great. All right. Yeah, you get that. I put too much water on the slide, so you get in this zone where they kind of go in and out of focus a lot. I may have to wait for some of them to come out. Anyway, the slime stuff used like for Alien, in the movie Alien, the jaws open up and the slime drips down and stuff. That's a stuff called methylcellulose. You make it up from a powder, and you have different thickness levels depending on how much water you add to it. And it's very clear, unless you purposely make it cloudy. That's a nice little specimen there. And anyway, so you put that, dilute that, put that on the slide, and you immediately create a thicker environment for these guys to swim through. So they have to put a lot more effort out, which means they swim a lot slower. And it gives you a chance to study the fast-moving guys, which is a lot of fun. Whoa, is that what I think it is? No, it's not changing shape. So that might be an amoeba there, but lots of dead plant material. There's another one. Oh, that's a nice one. That might be this one called Stylonchia. They have these shaped kind of like a paramecium. You can see the gullet on it. They have this oral groove thing. Acts like kind of like a mouth and a throat. But they have these little spiky bits on the top and the bottom. You can see the tapered end is like the top, essentially. That's the direction it swims in. And the top and bottom have these little spiky bits where the cilia fuse to form these structures called cirri. C-I-R-R-I. Kind of like thick hairs compared to the cilia, which are little tiny hair-like things. Anyway, they look spiky, kind of like a little crown on the top and bottom. It's very distinct in some of these animals. Stylonchia is one of them. But yeah, these guys are fun. I like these guys a lot. They don't move too fast. They have a lot of details. This one's moving kind of fast, but usually they're a little slower than this. I might take this whole slide and add that slime to it. Everything's too fast in general. Let me try. Whoa. Okay. Just for, ooh, another thing went cruising by there. I will try real quick. Can it take closer? Maybe a little bit closer. Just for fun. Oh, that's interesting. Wonder what that is. Looks like a sporangium. If you saw my video on the fungi in the cheese and the fungi growing on the bell pepper, and some of these structures came off the hyphae. This might be some kind of sporangium. Fungi are all over the place, so it wouldn't be surprising to find it in water because they blow around and get knocked around and could easily be found in water. So I'm not exactly sure what that is, but it does look like a little sporangium spore pouch thingy. Very cool. I have to go back to a lower power to find those guys. There's another small one that's going in circles. Where's he going? Where's he going? There it is. Yep, and out of focus. Too much water. There's some dead plant material. There's another one of those interesting. Oh, there's a nice single cell green character. So that would be a little photosynthetic flagellate. Very small though. There's a common one in culture. If you take a biology class or whatever, called Chlamydomonas, which good sized green cells. Oh, there's a huge one through there. Whoa! Oh, these are Vorticella. Oh, nice. This is a great slide. These are sweet, free swimming Vorticella. These little cup-like things that you don't often see them swimming like this. They're usually planted down on stuff, on little stalks. Boy, oh boy, it's a fast one. I never see them swimming. They're always attached. But they see the jerky movement they have. It's kind of bopping back and forth. If they feel irritated, it's like a defense thing. They'll pop around like that. And when they're on a stalk, the stalk will retract like a little coil, like a bed spring. But see them swimming free like this is interesting. Never see this. They have a ring of cilia near this kind of an oral opening thing. And it's using that plus some other cilia to move around. Man, oh man, there's some good stuff here. This is why I usually cover the whole slide if I can. As you saw, different areas of the slide are completely different little critters. There's another little character. Stuck Stuck in a little debris forest. Ooh, there's a Vorticella again. Or something like Vorticella. The other couple look like this. Very jerky. It's like they're very sensitive, they get irritated, and they just pop, just kind of get away from what they think is possible danger. If I can get a little more light in there. Let's change this light level a little bit. Get that color balance problem here. Let's try this again. Where'd it go? There you go. You can see it going up and down in the water, which makes it tough to follow these guys because you gotta go X, Y plus Z with the focus. And it's very challenging. Let's go back up here. See what else we may have missed. That's where the rotifer was. And you see the slide is starting to, this little arc of the water starting to advance. It's good low power. Where'd the rotifer go? Yeah, so everywhere outside this little boundary, this curved boundary, has dried up. All this area is now pretty dry. So anything that's still moving is inside that boundary. But where did the rotifer go? Weird. I wonder if I got squashed on something. It's the only kind of living area I got left to look at. There you see a couple of those little guys I was calling Vorticella. Can look like when they attach on a stalk that tiny little wine glasses. An open cup with a ring of cilia, and then the stem of the wine glass is like these little coil attachments they have. And when they're not attached, they look like this. Keep changing focus on these guys here. So that's these guys swimming here, and there's another one up here, which is like that little Stylonkia guy, or one like that. Saw it earlier. Where'd it go? Pretty easy to see. It went somewhere. So I will stick with these guys for a little bit. Since I'm not going too far. There it is. There's a little spiky guy. Let me zoom in again here. There's the spiky dude. You can see little spiky bits at the top and bottom. Make sure that focuses good here. It's kind of light colored compared to some other material here. There's that little green guy again. Single cell green guy. See if I can get a little closer to that one. Maybe. Maybe not. Where's the green one? Oh, there goes the little spiky one. That was a lucky shot there. I just swam right through. Too lucky. Too lucky. I'll find that green one real quick. I like that green one. Green one's loving this bright light on the scope because photosynthesis is kicking into overdrive. There's the spiky guy again. He's right near one of those, it's like a sporangia thing. Alright, he's not slowing down, so let's try a guess here and see if I can get lucky. Still kind of near the middle here. So if I can trace him. Yeah, he's taking big movements now. It's that little thing again. I lost him. Some yeah, can't get it. I have to go lower power. See if I can find the spheres over here moving around. There's a little flagellate of some kind, nondescript, kind of wiggling as it moves by. It's kind of a weak swimmer. Has that kind of wiggle movement when they, like a sperm cell does with the flagellum behind it. You can see the little wiggling motion of the body. It's not smooth and turning on a dime like a ciliate does. There's some bacteria in the background too, that's nice. Little zigzaggy bacteria moving around. Look carefully, you can see there's a couple different kinds of bacteria here actually. Some rods. Looks like some joined spheres called cocci. Like Staphylococcus aureus is a common bacterium that actually gives you the staph infection that everyone talks about all the time. It's Staphylococcus because it's made of spheres, it's all cocci. And there's a filamentous bacteria in there. See that little line of stuff flexing left and right in the middle? That's a little bacterial colony. Might even be a very small. Some of the blue-green algae have that kind of structure and they're very small sometimes. But it could just be a colonial bacteria. And that kind of wiggle dance there. There's no color to it, so it's probably a little bacterial colony. Alright, let's go lower and find those. This water level's moving fast. I don't get these things before these guys get squashed. Where are you guys? You're still swimming up here? There they are. Still two of them dancing around. Trying to get the color to look better. They're not really that colorful. The camera's doing some weird stuff to them, giving them kind of an orangey look. They're actually kind of clear with just a tiny hint of yellow orangey color. It's weird how they're getting enhanced color like that. Oh, so fast. Yeah, it's fun to see those guys free swimming. Usually see them attached. Try a trick here. Since the slide is starting to dry, I might be able to resurrect it and slow them down with a little bit of methylcellulose. See what we can do here. This might make it worse, but I'll give it a shot. Okay, now it's should be mixing and slowing things down. That's the problem when you tweak a slide a little bit, stuff gets moved all over the place. I can't find my little buddies. Oh, I'll make another one anyway. That was a really good slide. Lots of good stuff on there. Let's try one more for that bottle just because it was good. One more. Alright, let's see this one. What do we got here? Just a little bit better. Put a little less water on this time. Shame I missed that rotor for earlier. Those are really fun to watch. Got a bunch of them on my other videos. That's a dead material. Nothing moving. Oh, wait a minute, this one. Nice little ciliate there. Very nice. Let's do little pirouettes. Go, man, go. Unfortunately, it's off camera here. Need to adjust this because I got the slide in the wrong orientation. There we go. Now I can move it better. There. Yeah, lost them. Oh, there it is. Keep sliding through some stuff here. That's fun. Squeezing between little bits of debris. It's got crazy movement. I found one of these earlier in the other slide. It was much faster. I couldn't really follow it, but now it's nice to see. It's very thin. You see as it kind of rotates, it's kind of compressed. It's not like a paramecium is kind of like one of those cold capsules you take, or some vitamin pills that have that kind of round capsule. A lot of thickness. These guys are pretty thin, but still pretty long. And crazy spinners. Never saw one do this kind of spinning motion. That's fun. It swims for a while, then spins, and then swims for a while and spins. Really wild. Oh, it's very flexible. You can see it bend around that material. That's pretty cool. It's like going through things, bending around things, and then kind of spinning too. You can see the flatness when it spins along its axis. Oh, that's cool. Alright, let's go out and look for another thing. So I still have another bottle I want to look at. What brightness on this? Why is it? It's like the auto gain control is out of whack here. Okay. Not much else, but that spinner was pretty cool. So yeah, the spinner at 100x is pretty interesting. Oh, sorry, 40x. No? Wait, yeah, it was 100x. Cool. So that's bottle 2. Nice stuff. Now let's check bottle 3. Bottle 3 is the one that was a more established water set. Almost like a gutter puddle area in this other area, this park. Actually, no, wait, this is the, this is kind of a puddle debris area near one of the kind of sloughs going through the area by an industrial park. Just off a trail. So I couldn't get to the actual mud area. Like I said, I went down there, would have slipped and fallen into the water, or would have lost a shoe probably. Maybe something good here, you never know. Nope. Pretty boring so far. What's that there? kinds of little debris bits. Picked up some kind of mud with it too, so you're seeing like crystals of stuff and other bits that would make up the mud. Yep, nothing there. Let's try another slide. Might be some guys near the bottom. Have to stir it up a bit. Okay, let's see what we got on this one. Let's see what we got on this one. Plant material. Little bits of crystals and bits. Nothing moving there. There's a industrial fiber there. So it's kind of bluish color. It's definitely not natural. Hope this light picks it up here. It's still kind of dark. If I defocus it, you should be able to see it's kind of blue. A bluish color. Some man-made fiber there. Well, it was a pretty boring one, so that's it for the bottles. I also wanted to try doing a couple of other fun things. Do some colloids now. If you don't know what a colloid is, it's a liquid suspension. Classic examples are milk, and I suppose paint would also be a colloid. It's basically water-based liquid, or sometimes oil-based, and then paint pigments and other bits floating in there, creating a matrix of. So you do have to mix it because it separates, but when you mix it, it's a semi-stable fluid, at least for a bit. And same with milk. Milk can separate as well, which you get, especially the heavier stuff where you get the cream on the top. So what I wanted to do was take a little bit of milk and compare it with almond milk, just to see what kind of particles you can see in the liquid. It's going to be fat globules and other kinds of stuff. Alright, let's see what we got here. So again, there's like a gradient. You see stuff kind of floating by. Little particles of stuff. Lots of air bubbles. Let's get to the edge of the slide here. So we're getting a weird, almost like a polarization kind of color shift there. Should not be that color from milk. It's very unusual to look reddish like that. It's not supposed to do that. That's a weird artifact. Anyway, so you've got you can see a series of particles here, but it still looks kind of orangey, which is really odd. There you can see the stuff kind of floating by. Particles floating by. I don't know why it looks reddish orange like that. Zoom a little bit more. This is now 400 power. There you go. You can see all the little suspension particles that make milk. It's like fat globules and protein bits and stuff. And they're kind of wiggling because, oh, I know why. This camera's stuck, I think. Let's see, why is the camera stuck? There we go. That's what I wanted to see. So you can see all the milk particles kind of swirling about from temperature gradients and general diffusion, and you can see their different sizes, like fat globules and protein bits and all that stuff. And then there's a bit of a randomness, kind of like how bacteria will dance in place from Brownian motion from the heat of the lamp. Unfortunately, that little pink thing in the center is a weird issue I have with this camera. I need to look into it, but ignore the pink spot in the center. That's an artifact. But you can see I'm actually breathing on the slide a little bit. Very susceptible to just the slightest bit of wind pressure. But there's the particle dance from milk. And again, this is pretty high power. This is 400 power, which normally some of the cells I showed you earlier would be quite large. But these are these tiny little globules and stuff in milk. This is a different kind of milk too. My girlfriend is lactose intolerant, so this is lactate 2% milk. So that also makes a difference because by processing it to remove the lactose, you're also changing some of the chemistry of the milk to, it's going to look different. I should have a standard 2% for comparison. But what I'm going to do now is put in this brand of almond milk that I like, because it's not sweet and it has get this in this dish here. Not sweet, has a little bit of vanilla flavor to it. And it's good with cereal. It's not very heavy. And back when I was vegan, it was kind of important to have a completely non-dairy milk, and it's just a habit. You know, I'm just vegetarian now. It's nice to have something, just an old habit that I like to drink it. Tastes pretty good. But it has a very different consistency because, again, it's made of, similar to how you make cheese. You grind up the stuff, you process it, then you press it through like a cheesecloth type thing, and you basically get the oils of the almond and the some of the soluble bits, at least enough soluble enough to make a colloid. It's not chunky and chewy like an almond would be. And they add some other stuff to it as well, of course. But let's check out the almond milk. This is Silk brand almond milk. Slightly different color, different consistency, certainly compared to the 2% here. And there you go. It's a bit more viscous too, so there's a little bit more stuff going on at the lower power. This is low power. You see all kinds of stuff there. The camera's frozen again. Come on, man. There we go. So that's a 4 power. There's quite a bit of detail at 4 power. Let's go a little closer. There's all kinds of stuff in there. Look at that. Various particles of different sizes. I imagine the big dark bits are remnants of the processed almonds, but hard to say. They're small enough that you wouldn't notice them as a solid in your body, in your mouth at least. And let's go up to the power we had before for the milk. It's 400 power. Lots of different particle sizes. I notice they're not dancing around as much. This stuff is thicker than the other milk, so it's less watery and it's less movement from the heat. A little bit, you can see a little bit of a dance there, the particles. But very different than the milk, which is much more watery, and you see the particles streaming around. Cool. And I thought, just for hell of it, I would have a couple more colloids here. Let's do be right back. I gotta rinse these guys out. Alright, a couple more quick examples for in the stream. Been going for a while here. At least almost 2.5 hours. Some more colloids. So one good example is enchilada sauce. It's just a canned one I use because it's convenient. I'm not really a Mexican cooking expert, so doctored up a little bit, but this is right out of the container, and makes nice quesadillas and burrito fixings with this added to it. So it's just a little bit of this. So yeah, it's tomato based, chili based, so it should have plenty of solids in it. Have a nice color there. Oh yeah, there you go. Look at all that stuff. There's an air bubble moving through it too. That's wild. So you can see chunks of tomato, chunks of chili, little particles dancing around as a gradient sort themselves out. Almost like blood flow there a little bit. So yeah, lots of colors. Lots of little things flowing around, different colors, different structures, particle sizes. After a while, this would settle out. You would have all these particles dancing around. So that's enchilada sauce. That's low power. Let's go just one more in just to see what we got. Oh, that's cool. Look at that. All that movement. Let's go over here a little bit. Let's make some more bio art. You can make a screensaver out of this. Or use it for some horrible special effects for a movie. And you know, there's a lot of stuff added to this. There's like vinegar in this ingredients: vinegar, tomato paste, chilies, various other spices to make this enchilada sauce. So there you go. There's that. Another example of colloid, or colloidal suspension is another term for it. And let's do, you know what, let's go a little higher just for fun. We're already here. Let's just see what we can see. Now we get really tiny particles floating around. This looks downright like stuff inside of an organism when it's really just a sauce on a slide. It's pretty fun. Shows to somebody they have no idea what they're looking at. Now when I rinsed out the cups, there's a residual water. So this is a colloid added to water, and the water is kind of forcing some of this balance where the sauce is pretty stable, but adding water to it now, it's having to figure out a new balance. So there you go, that's that. And let me now this is going to be kind of a more natural brand of a sriracha sauce, another famous chili type sauce. So this is not the typical one you'd buy or find in the Vietnamese places for pho, but this is probably a little bit, maybe a little bit thicker, and maybe slightly better ingredients. It's not a cheap sauce, and I'm not going to dilute it. I'm just going to put a drop of it on the slide and see how that looks. Might be very dense, we'll see. Here we go. Actually, it's very similar, but it's also very colorful. Look at those oil droplets. That's cool. Got that chili oil in there. Gives you a lot of flavor. But oil and water makes, they don't mix. So the oil droplets form a perfect sphere, which is nature's favorite shape when it comes to these liquids. It's the simple, compact shape that things form. Water droplets and oil droplets and all that good stuff. And you can just marvel at that for a bit. Another beautiful shot. More bio art. It's a little bit of movement in the background. Some particles sorting themselves out. Diffusion. Not too much though. I'll have to zoom in on some of it because it's pretty small. A couple oil droplets are moving. That's fun. Let's zoom in on that area where the oil droplets are moving. That's cool. Some of that going on right here. Some of the bigger and mostly smaller oil droplets moving around. There's some down here too. Droplets moving around. Very interesting colors and shapes. Let's cruise around, find some other spots that are interesting. That color really pops. It's pretty cool. It's almost, if you darken this up a bit, it looks almost like some really cool space art. Little planetary shapes and moons and such. black hole music generator is perfect for this. Very ethereal and creepy, almost. Space music. There's some big clusters of oil droplets in some of these areas. Look at that. It's nuts. And just for kicks, I'm going to zoom in real quick. One more level, go to 400 power. Let's try that now. Oh, that was cool. Oil droplets joining together. Alright, there you go. Another colloid. Some sriracha type hot sauce, just a different brand. Alright, that's good stuff. That was it for tonight. We got some little kitchen experiments as well as some nice water samples from the local park, the parking lot nearby, strip mall and all that stuff. So yeah, good little critters. I'll have to add some chapters later, help find stuff a little bit easier. So if you want to watch a replay or show it to anybody else, feel free to make any comments in the comment section. I didn't have anyone join me on this stream. Everyone's busy on a Saturday night or they're sleeping. I don't blame them. I actually went to see Chris Rock and Dave Chappelle tonight in San Jose. It was a good show. Horrible story of the way they ran the security in it. We're standing out in the rain for about 2 hours, maybe a little more than that, just to get into the building. And then going through security, and then finally going through the massive crowd to get to a seat, and literally just getting into my seat, watch a little bit of the opening music act before Chris Rock started, and that's ridiculous considering I got there probably about 6:30, roughly. Get some parking, which is nuts. And then from 6:30, walking over to the mess of people, finding out there's this giant snaking line going all the way around the sidewalks, and staying out there with an umbrella. Thank goodness I brought an umbrella because it's raining. For a good 2 hours, 2.5 hours almost. So glad I got there when I did, because there was a line behind, as I was getting in the building, there was a line behind me just as long as the line I got in when I started. So I'm sure some of those people missed either a good portion of Chris Rock, or maybe completely missed him potentially if they're still coming in, which is totally insane. So yeah, crazy stuff. SAP Arena needs to get their act together because that was ridiculous. But it was a good show, and had some little energy left and some samples from today I wanted to show. So thanks again for watching the replay. Like I said, I didn't get anyone on the live stream, which I understand it was a late night stream. but no chatties in the stream. So, yeah, good times, and thanks again to anyone who watches it, comments, participates, etc., etc. Keep thinking up. If you have any ideas, any requests you want me to look at, feel free to put them in the comments or join the live chat for next time. And instead of keep looking up for astronomy, I'd say keep looking down. Start looking more at the macro world and the micro world if you can. And enjoy science as much as you can. It's a lot of fun. Thanks, everybody. Have a good one.